We have a neon lamp here. Its I-U relationship at the right side strikes, this lamp strikes at 120 volt, which means that below this voltage this resistance is infinitely large. Then we have a voltage source of 120. We have a circuit at the left that strikes this lamp. Capacitor in parallel, its value is 5 microfarad. Then we have a switch which closes at t equals 0 and DC source of 200 volt. And our task is to size this resistance such that this voltage of 120 volt is reached after 5 seconds, after closing the switch. We may solve this problem by means of PSpice simulation. At first, a version of PSpice that is not using schematics, I mean a netlist is created manually. We have a switch modeled here, and we have results of performance analysis. It is much easier to replace switch and voltage source connected in series by piecewise linear source, and let me show using PSpice schematics how to do this. So we have our source, piecewise linear source, taken from the library. At 0, we have 0 at 0.1 microsecond, a small time compared to time of transient analysis. We have 200 volt, and then arbitrary time, let's say 20 seconds, the same 200 volts. So we have a step here. Its magnitude is 200 volt. A transition rise time is 0.1 microsecond, which should be enough. Then we have a parameter, so the value of this resistances are variable in brackets. We have to also, this information should be included in parameters window. Then we have to fill the analysis setup window, the transient analysis from 0 to 6 seconds, and our parameter variable resistance, global parameter, decade sweep type, and these are start and end value, are all selected experimentally. If these data are ready, we may save them and start simulation. When simulation is completed, we have to select the performance analysis to replace time by R variable, and then we may find, using this window, we may find a value of resistance for voltage at 5 seconds at the level of 120 volt. Now, briefly, very briefly, let me repeat this simulation. Circuit diagram already stored in computer memory. So we have a variable resistance here, variable resistance R var in brackets, and we have a piecewise linear source, and we have set these values T1, V1, T2, V2, T3, and V3. Each time when we add a value, we have to save the attribute. Then, obviously, in this box, we have to set that name of our parameters is R variable without brackets, and this value is arbitrary. The values of these parameters, they will be set by performance analysis setup. Performance analysis setup, parametric analysis, R var from 100k to 10 mega with 100 points per decade. Global parameter, what regards our transient, well, 6 seconds is enough. Anyway, we are interested only to trace our output up till 5 seconds. Okay, then we have to store these data in computer memory and run a simulation. So simulation will be completed in a second. We obviously select all values of resistance, and we have a blank window with time on horizontal axis. We don't want time here, we want a performance analysis, and we click performance analysis here. And now we have a variable resistance. Now we have to add trace, and our trace is y is VC1 at 5 seconds. It is capacitor voltage at 5 seconds. Okay, so we have a capacitor voltage at 5 seconds for different values of resistance. Now we are interested to find resistance such that this voltage reaches a level of 120. And the best way to find this is to click the toggle cursor, then search command and search forward level 120. Okay, we have this value. That's the value of resistance that we are looking for. That way we have completed simulations.